For decades, China's military planners called American aircraft carriers floating coffins, billion-dollar targets waiting to be sunk. On state television, generals laughed as they unveiled the DF-21D, the so-called carrier-killer missile designed to turn the United States Navy's pride into underwater graveyards. Beijing bet everything on one strategy: keep American carriers so far from shore that their jets could never reach Chinese soil. But then, in 2017, the United States commissioned a vessel that broke every rule China thought it understood: the USS Gerald R. A ship so advanced that it does not just launch more aircraft, it redefines what naval power means in the 21st century. What made China's laughter stop the moment this supercarrier left port? And why did their entire anti-access strategy crumble when American engineers revealed what was hiding beneath the flight deck? Let us pull back the curtain on the warship that turned the Pacific from a Chinese lake back into open water. In 2013, Chinese state media could barely contain its excitement. Parade footage showed the DF-21D missile rolling through Tiananmen Square, its angular nose cone pointed skyward like a dagger aimed at the heart of American sea power. Anchors called it the ultimate asymmetric weapon, a missile that cost $10 million, designed to destroy a carrier worth $13 billion. The math, they argued, was devastating. For every carrier the United States risked, China could build 100 missiles. Admirals in Beijing commissioned studies showing that a single DF-21D strike could cripple a Nimitz-class carrier, leaving it dead in the water, burning and defenseless. The message to Washington was clear: your carriers are relics, expensive, slow, and vulnerable. The age of American naval dominance is over. The DF-21D was not just propaganda. It was a real threat backed by real technology. The missile used a maneuverable re-entry vehicle, a warhead that could adjust its course mid-flight, dodging defensive fire as it plunged toward its target at Mach 10. Radar satellites tracked carrier groups across the Pacific, feeding coordinates to launch sites hidden deep inland. On paper, it was the perfect counter, a weapon that could strike from 1,000 miles away, far beyond the range of any carrier-based aircraft. Chinese military journals published detailed kill chains, step-by-step guides showing how a coordinated salvo could overwhelm American defenses. Each article ended with the same conclusion: the era of the aircraft carrier is finished. But the analysts who wrote those reports made one critical mistake. They assumed American carriers would stay the same: slow to launch aircraft, hungry for fuel, limited by 1960s technology wrapped in a modern hull. They assumed wrong. On July 22, 2017, the USS Gerald R. CVN-78 slid into the waters of the James River in Virginia. It looked like a carrier: a flight deck, an island superstructure, and arresting wires for landing jets. But beneath that familiar silhouette, everything had changed. The Ford was not an upgrade, it was a revolution. The first shock came from the catapults. For 60 years, American carriers used steam catapults to hurl jets into the sky. It was a system of pistons, valves, and superheated water that required a small army of engineers and broke down constantly. Every launch sent a plume of steam roaring across the deck, wasting energy and limiting how fast the next jet could take off. The Ford replaced all of that with the electromagnetic aircraft launch system, EMALS. No steam, no pistons, just raw electromagnetic force, the same principle that powers a railgun. EMALS uses linear induction motors to accelerate aircraft from 0 to 170 miles per hour in under 2 seconds. The system is smoother, putting less stress on airframes and extending the life of every jet that uses it. But the real advantage is speed. A steam catapult needs 5 minutes to reset between launches. EMALS is ready in seconds. The Ford can launch 25% more aircraft per day than any Nimitz-class carrier. That is not an incremental improvement. That is the difference between controlling the sky and losing it. Then came the Advanced Arresting Gear, AAG. Landing on a carrier is controlled violence. A 30-ton jet slams onto a pitching deck at 150 miles per hour, snags a wire, and is yanked to a stop in under 350 feet. On older carriers, that wire is connected to massive hydraulic systems that absorb the shock. The problem is, those systems can only handle a narrow range of aircraft weights. Too light, and the jet gets jerked so hard it risks structural damage. Too heavy, and the wire can snap. The Ford's Advanced Arresting Gear uses water turbines and computerized controls to adjust the stopping force in real time, tailored to each aircraft. That means the Ford can recover everything from a lightweight drone to a fully loaded F-35C without breaking a sweat. More flexibility, more sorties, more lethality. But the most important upgrade is the one no one can see. The Ford power plant generates 250% more electrical power than a Nimitz-class carrier. Why does that matter? Because modern warfare runs on electricity. Radar systems that can track hundreds of targets simultaneously. Electronic warfare suites that jam enemy missiles. And coming soon, directed energy weapons. Lasers that can burn drones out of the sky for the cost of a gallon of diesel. The Ford was built to carry weapons that do not exist yet, but will dominate the next 50 years of naval combat. When the Ford's capabilities became public, Chinese military planners went silent. The DF-21D was designed to exploit a weakness. It assumed carriers could only launch 12 jets per hour, that they needed to sail close to shore to strike inland targets, and that they were slow to adapt and expensive to defend. The Ford made every one of those assumptions obsolete. With the Electromagnetic Aircraft Launch System, EMALS, the Ford can surge launch a full air wing in under 30 minutes. That is 75 aircraft in the sky before a Chinese missile battery can finish its second salvo. Those jets are not the F-18 Super Hornets that Beijing's war games assumed. They are F-35C Lightning IIs. Fifth-generation stealth fighters with radar cross-sections smaller than a golf ball. Aircraft that can penetrate Chinese airspace undetected, strike targets with precision-guided munitions, and vanish before the enemy even knows they were there. The Ford does not need to sail within 500 miles of the Chinese coast. It can sit 1,000 miles offshore, far beyond the reach of DF-21D, and still project devastating firepower. The so-called carrier killer was designed to hunt a ship that no longer exists. Then came the real surprise. In 2023, the Navy tested a prototype laser weapon aboard the Ford during a routine deployment. The test was classified, but the results leaked. It was a 150 kilowatt solid-state laser capable of engaging drones, small boats, and incoming missiles at the speed of light. No reload time, no ammunition, just raw energy drawn from the ship's electrical grid. The cost per shot was less than $1. Compare that to a Standard Missile-2, which costs $3 million each. The math is staggering. A Ford-class carrier with fully integrated directed energy weapons could engage hundreds of targets per day for the price of running the air conditioning. Chinese planners had built their entire strategy around overwhelming American defenses with sheer numbers. Launch 50 missiles, assume 10 get through, call it a win. But directed energy weapons flip the equation. Suddenly, volume does not matter. The laser never runs out, it never misses, and it never stops. Back in Beijing, the tone changed. State media stopped calling carriers floating coffins. Instead, they published articles about China's own carrier program, emphasizing homegrown technology and self-reliance. The DF-21D still rolls through parades, but the boasting has quieted. Everyone knows the truth. The weapon that was supposed to end American naval dominance has become a footnote, a relic of a strategy that died the moment the Ford proved what 21st century sea power really looks like. Today, the Ford is not alone. The USS John F. Kennedy, CVN-79, is under construction and will join the fleet soon. The USS Enterprise, CVN-80, is already being built. Each one faster, cheaper, and more lethal than the last. The lessons learned from the Ford's first years have been baked into every new hull. Digital engineering and modular construction mean the Navy can build these ships in less time and for less money than the last generation of carriers. The Ford class is not a one-off experiment. It is the future, mass-produced and battle-ready. China's admirals now face a choice: invest billions more in missiles that might not work, or admit that the carrier is not obsolete, it just evolved beyond their ability to counter it. The DF-21D was a good idea in 2010, but this is not 2010 anymore. Right now, the USS Gerald R. Ford sails the Atlantic, a floating city of 4,500 sailors and 75 of the most advanced aircraft ever built. It does not need to prove itself with parades or propaganda. It just needs to exist. That is, deterrence. Not the threat of destruction, but the certainty that any adversary who tries will fail. The Ford is not just a ship, it is a message. American innovation does not stand still, and betting against it has never ended well. If this is the kind of power that keeps the seas open and freedom afloat, drop a comment below.